So most people ask me, both internally and externally, how do I communicate my filter appropriately? How do I speak the language, and how do I understand how my filter will be used in my system? Well, here are 5 critical system requirements that we like to communicate to our customers and to our partners. Angle of incidence is extremely important because this dictates the nature in which your filter will react to a lighting condition. Things known as nominal angle, where it comes on straight on at 0 degrees, or things known as cone and half cone angle, where you have a varying divergent light source. Ultimately, that will change the performance of your filter. Substrate, there's a variety of materials that can be used, different grades, different flatnesses, and different qualities. Size and shape, obviously your dimension, the larger your substrate, the more expensive your filter will be. The thicker your substrate, the more expensive your filter will be, and the tighter the tolerances, the more expensive your filter will be. Environmental and spectral, again, the last 2 that we see here. Environmental is not as important as the other 4, but still worth mentioning. Things like robustness or humidity or temperature requirements, these are more tightly defined in defense and outdoor applications, but we'll cover that quickly going forward. Last but not least, spectral, which is the most important. This defines your wavelength range, your blocking, and the overall profile of your filter. Try to keep these broad, try to keep these locked into a close standard filter, and your costs will be reduced. So first, angular performance. We'll look at, on the left, a collimated type of approach where you have a varying angle of incidence from 0 degrees up to 15 to 18 degrees, and lastly 30 degrees. So the curve will start further on the right. As your angle of incidence changes, you have a spectral shift to the left, so we call that a blue shift. Roughly, when you're talking 15 to 18 degrees, that's roughly 5% of your center wavelength. As you go above 30, get close to 45 degrees, it's really tough for us to give you an accurate measurement because it's so wildly dependent on the light you're using and how the filter is integrated into your system. But take into account, angle of incidence changes your center wavelength. Cone angle, if you start with a filter that has very sharp edges, as you adjust that up to 15 or 18 degrees, you're going to see a shift to more of a pyramid conic structure. As you go even further, that's going to flatten out and drop your transmission significantly and look more like a mound or a hill. This seriously degrades the performance of your filter and can change things wildly, so we need to take that into account when designing your system. On the contrary, angular performance does not really affect anti-reflective coatings, and that's why AR coatings are so widely used in a number of applications, definitely in the machine vision and automation world. So you're not going to get much of a difference as you change angle of incidence or as you change your cone angle when it comes to AR coating. So these are widely used in systems where there's broadband light sources, a very large angular change, or a very large cone angle.